Today, we're going to talk about two main topics in the notes. We're going to talk about how to find all the trig functions from knowing the value of one trig functions, as well as we're also going to talk about solving some basic trig equations. So before we can do our first part of this, which is finding all the trig values from knowing the value of one trig function, we first of all have to talk about a whole category of trig functions that you probably have heard of, but maybe aren't 100% sure of what they are. So I'm going to teach you today about three new trig functions. These are called the reciprocal trig functions. Their names are cosecant, secant, and cotangent. So the abbreviations for that are CSC for cosecant, SEC for secant, and COT for cotangent. Now, the reason these are called the reciprocal trig functions is because they're literally built of a reciprocal of a function that we've already talked about. So cosecant is the reciprocal of sine. So in other words, 1 over sine. Secant's the reciprocal of cosine, so 1 over cosine. And cotangent, of course, is the reciprocal of tangent. If you think about the sides that go into making these functions, since sine is made of opposite over hypotenuse, cosecant's going to be made of hypotenuse over opposite. Secant, being the reciprocal of cosine, is going to be hypotenuse over adjacent, and cotangent, being the reciprocal of tangent, is going to be adjacent over opposite. Now, if you think back to our lesson on the unit circle, we learned that the y-coordinate was sine, so cosecant is going to be 1 over y. We learned that x-coordinate was cosine, so secant is going to be 1 over x. And we learned that tangent was made of y divided by x, those coordinates on the unit circle, so that means cotangent is going to be x divided by y. So now that we know about those three reciprocal trig functions, and we put that together with the three that we already had, now we have a total of 6 trig functions. What we're going to do is we're going to talk about using one trig function to help us find all 5 of the others. So the first thing that has to happen here is we have to determine what quadrant the angle is occurring in and write it down. So make sure you know what quadrant you're in. Second step is to draw a picture of a right triangle and put the lengths of the sides that you know into the picture. Now, here's where I might do something a little different than the teachers that you had last year. I only put positive lengths into my picture because technically negative lengths don't really make any sense. So what I do is I wait until the end of the problem if there are going to be negative trig ratios, and I'll put the negatives only on at the end. All right, step number 3, we're going to determine the length of the third side of the triangle by using Pythagorean theorem. In other words, a squared plus b squared equals c squared. Remember, c would be the hypotenuse in the right triangle. That's the one on the side by itself. Step number 4, we're going to use the lengths of all 3 sides of the triangle to help us build the fractions that represent the unknown trig ratios. And then fifth and final step, we're going to use the information about the quadrant that we're in, which we figured out in step 1, together with the chart all students take calculus to determine which, if any, of the trig ratios need to be negated. So again, if you're in quadrant 1, all your trig functions are positive, but in quadrant 2 it's sine, in quadrant 3 it's tangent, in quadrant 4 it's cosine. Now here's something that we need to know. The chart is really just built for the basic 3 trig functions, sine, cosine, tangent. Remember, when you flip something over, that does not change its sign. So if sine is positive in quadrant 2, that means cosecant is also positive in quadrant 2. That's the reciprocal of sine. If tangent's positive in quadrant 3, that means cotangent's positive in quadrant 3. And if cosine's positive in quadrant 4, that means secant's positive in quadrant 4. So when you flip something over, in other words, the reciprocal trig functions have the same sign as their base function that they come from. All right. Let's now try a couple of examples, and I'll walk you through all the steps that we're going to go through in order to figure out all of our trig functions here. Example number 1, they're going to tell us that the cosine of some angle x is negative 2/3. And also they're telling us that the sine of angle x is less than 0. So if I start trying to figure out what quadrant I'm in, I usually do this by process of elimination. I make my little all students take calculus chart, and they're telling us that cosine's negative. So that means we are not in quadrant 1 and we are not in quadrant 4. And they're also telling me that sine is less than 0. That means sine is negative as well. So that means it can't be quadrant 2 either. So by process of elimination, the only quadrant that I could be in is quadrant 3. Now, step number 2 is to build yourself a picture of a right triangle. So here's my right triangle. Here's angle x. Now they told me that the cosine was negative 2/3. So That means the adjacent side is 2 and the hypotenuse side is 3 because cosine is built out of adjacent over hypotenuse. I'm not going to put the negative into the picture because technically lengths should be lengths should be positive. A negative length wouldn't make sense here. We're now going to have to use Pythagorean theorem to figure out what the missing side is in this problem. The missing side, by the way, would be the opposite side. So 2 squared plus y squared is going to equal 3 squared. So 2 squared is 4, and 3 squared is 9. And if you subtract the 4 over to the other side, you're going to get that y squared equals 5. And when you take the square root of both sides, you're going to figure out the missing side in this picture is the square root of 5. So now, what I'm going to do next is I'm going to build all the other trig ratios that we don't already have. We already got cosine, but we don't have sine yet. Sine is going to be built out of opposite over hypotenuse, so that's going to be radical 5 over 3, because radical 5 is my opposite side and 3 is my hypotenuse. We don't have tangent yet. Tangent is built of opposite over adjacent. So that's going to be radical 5 over 2. And cosecant, which is the reciprocal of sine, cosecant is going to be 3 over radical 5. And secant, which is the reciprocal of cosine, is going to be the reciprocal of negative 2/3, would be negative 3/2. And last but not least is going to be cotangent, which is the reciprocal of tangent. Remember, the nice part about this is we do not have to worry about rationalizing denominators. So if we get a radical 5 in the bottom part of the fraction, we just leave it. Now, the one last thing that has to happen at the end of this problem is you have to go back and look at what quadrant you're in. We're in quadrant 3. And in quadrant 3, we know that sine is going to be positive, and therefore its reciprocal function of cosecant is going to be positive, but everybody else should be, in quadrant 3, tangent is going to be positive, and cotangent is going to be positive. So these are the positive ones, tangent and cotangent, and everybody else should be negative. So sine should be negative, cosecant should be negative, and also cosine and secant should be negative. Okay. Let's try one more of these before moving on to our second topic. So the next one tells us that cosine of x is 8 over 17, and the tangent of x is less than 0. So if we build our all students take calculus chart that tells us where things are positive and negative, and we're looking at the fact that cosine is a positive 8 over 7, that means you're not in quadrant 2 and you're not in quadrant 3. So cosines are positive in quadrants 1 and 4. That's my option so far. And then for it telling me that the tangent of x is less than 0 means you can't be in quadrant 1 because everybody's positive in quadrant 1. That pretty much eliminates me all the way down to only having one choice left. That means this must be happening in quadrant 4. I'm now going to build a picture of the right triangle that they're describing. So this angle x has a cosine of 8 over 17. So that means my adjacent side is the 8 and my hypotenuse side is the 17. We're going to use Pythagorean theorem. 17 squared equals 8 squared plus y squared to help us figure out the missing side, which would be your opposite side. And 17 squared is 289, 8 squared is 64. If you subtract the 64 over each other side, you're going to get 225 equals y squared, and that means y is 15. So this one actually works out to be a nice whole number. This is actually called a Pythagorean triplet. So we now know all three sides in our triangle. We've already learned what the cosine is, so let's do secant next. Secant, which is the reciprocal of cosine, is going to be 17 over 8. Sine, which is built out of opposite over hypotenuse, is going to be 15 over 17. Tangent, which is built of opposite over adjacent, is going to be 15 over 8. Cosecant, which is the reciprocal of sine, is going to be 17 over 15. And cotangent, which is the reciprocal of tangent, is going to be 8 over 15. So again, I just build all those fractions based off of the triangle that I have in this picture over here. But now I have to go back and figure out if I'm in quadrant 4, which of these need to be positive and which of these need to be negative. In quadrant 4, cosine would be positive and secant would be positive, but everybody else, sine, tangent, cosecant, and cotangent would all be negative. So we have to add the negative signs onto all of those. All right, the last thing we're going to talk about in today's notes is how to solve a basic trig equation. So for now, what we're going to do is we're only going to focus on answers that are in quadrant number 1. In other words, that means the angles that we're going to be looking for are going to be between 0 and 90 degrees. And we'll probably be doing this in degrees and not radians at first because this will make a lot more sense to you. So there are 3 basic steps that you want to go through to solve a basic trig equation. And what I mean by that is we're going to be looking for the missing angles that would make the sentence true. So step number 1 would be to isolate the trig function on one side of the equation. So whatever your trig function is, whether it's sine, cosine, or tangent, or one of the reciprocal trig functions, get it all by itself on one side of the equation. If it's one that you recognize from our tables, like for example, if it's sine of theta equals 1/2, and you're like, oh, I know this one from our tables, the angle that sine is 1/2 is 30 degrees. You could just do it that way. But if it's one of the ones that you don't recognize, if it's not one that you recognize, that's when you're going to have to use the inverse trig buttons on your calculator. Remember, whenever you want to ask your calculator what is the angle that has a specific value, that's when you're using inverse sine, inverse cosine, or inverse tangent. And to get to those buttons on your calculator, you have to use the second button first. So let's take a look at a couple of examples, and we'll show you how to do problems like this. Number 1 is actually going to be pretty easy because our trig function, cosine of theta, is already totally all by itself. So our first step would be to isolate, but it's already alone. And then the second step is to see if it's one that you recognize, which I hope everybody in this class recognizes this one. I am looking for an angle whose cosine value is radical 3/2. You should know this one, and this angle is 30 degrees. If you didn't recognize that, you're going to definitely want to go back and take another look at those charts of the special angles that we're supposed to know. All right, let's take a look at number 2. Number 2 says radical 3 times cotangent of theta equals 1. Well, the trig function in this problem is cotangent, and it is currently not by itself. So the first thing that you'd want to do to both sides of this equation is divide both sides by radical 3. Now, the next thing that you're going to notice is we have a cotangent. And you're going to say, well, wait a second. We didn't memorize cotangent values, nor do we have a cotangent button on our graphing calculator. So what you're going to want to do here is you're going to want to take both sides of the equation and flip them over. In other words, take the reciprocal. If you take the reciprocal of cotangent, you're just going to get tangent. And that means if you take the reciprocal on the left-hand side to turn cotangent into tangent, that means you have to take the reciprocal on the right-hand side, which would make 1 over radical 3 become just radical 3, or technically radical 3/1. Now, hopefully, again, this is an angle that you recognize. The angle whose tangent is radical 3 is 60 degrees. So theta equals 60 degrees. If you didn't know that, you could hit second tangent and put in radical 3, and the calculator would tell you what that angle is. As long as you're in degree mode, you'll get your answer in degrees. Now, number 3 is going to be the toughest one that we have in today's notes. The trig function here is cosecant. And as you can see, cosecant is not currently by itself. So we're going to start here by subtracting 2 from both sides. So that's going to be 4 cosecant theta equals 15. And then we're going to divide both sides by 4. So you're going to get cosecant theta equals 15 over 4. And then what you're going to have to do, much like we did in our previous problem, you're going to say, I don't have a cosecant button on my calculator, and you don't, because you can take both sides of this equation and take the reciprocal. So the reciprocal of cosecant is sine, and if you're going to do that to the left-hand side, that means you have to take the reciprocal on the right-hand side as well. So the reciprocal of 15 over 4 is 4 over 15. So I am looking for an angle whose sine value is 4 over 15. This is definitely not one that we've memorized from our chart. So on your calculator, in order to get the answer for theta, you're going to want to do inverse sine. So you're asking the calculator what is the angle that has, and you want to do 4 over 15 inside the parentheses that your trig function will, that your calculator will open up. And now here's where you got to be careful. Make sure that your calculator is in degree mode. Otherwise, you won't get the answer that I get. You'll get the radian version of this. I'm going to get an angle that's about 15.466 degrees. Now, if your calculator was in radian mode, you'd get an answer for this that's like about 0.24 or something like that. Well, if you see something weird like that, that probably means you're in radian mode, and double check your calculator and get it to degree mode if you want your answers to be in degrees. All right, that's the end of the notes for today. Give your homework a shot tonight, and we'll go over it tomorrow.